We have long distinguished ourselves from other species by our capacity for abstraction. We dream of faraway worlds, plan for the distant future, and invent elaborate systems to make sense of nature and our place in it. Through stories, language, and symbols, we shape the intangible into something we can grasp and harness. In doing so, we have created towering structures of meaning and value. We've launched probes to distant planets. We've split the atom and mapped the human genome. Yet amid these monumental achievements, a quieter revolution is underway. A revolution that threatens to transform us not from without, but from within. As technology becomes increasingly entwined with our biology, we are being transformed into something new, something that defies easy definition, something that could change everything. Join me today on a journey into the very essence of what makes us us, for this is the story of the bio-digital merge, and this is your host. Let's start with a question. How do you feel today? Maybe great, maybe not so great. It depends, doesn't it, on how well you slept last night, whether you ate something questionable for lunch, or perhaps the weather outside. You see, whether you realize it or not, your physical and mental state is constantly fluctuating, influenced by an endless number of factors. Until recently, capturing and analyzing this data was a laborious task. Blood tests provided snapshots of your chemistry, while cardiograms and EEGs offered glimpses into specific systems. These methods were invaluable, but they were periodic, invasive, and unable to provide a holistic view of your well-being. But that's changing. Thanks to advances in nanotechnology, we are entering an era where biometric data flows from your body to the cloud in real time. Devices like smartwatches already provide a wealth of information, tracking your heartbeat, sleep patterns, and even stress levels. But imagine if these devices could do much more. Picture a microscopic sensor floating in your bloodstream, a pacemaker that monitors your cardiac rhythm, or an insulin pump that analyzes your glucose levels. Suddenly, your body is not just a vessel, but a node on a vast network, generating and transmitting information that could help you live a healthier life. This isn't science fiction. It's the Internet of Bodies. The concept might sound alarming, but it's rapidly becoming a reality. According to Markets and Markets, the global implantable medical devices market will reach nearly $256 billion by 2028. But why is this convergence of technology and biology such a big deal? Because it's not just about convenience or efficiency, it's about redefining what it means to be human. When our bodies become the next tech platform, we open up a Pandora's box of possibilities and challenges. But to truly appreciate its impact, we must first understand the driving forces behind this revolution. The first force propelling the bio-digital convergence is a quiet hum that drives many technological advancements: Moore's Law. In the 1960s, Gordon Moore, the co-founder of Intel, noticed a trend in the semiconductor industry. Computing power was doubling every 2 years, and he predicted this trend would continue for at least another decade. Decades later, this observation, known as Moore's Law, continues to hold true, thanks to advancements in nanotechnology. We are squeezing more transistors into smaller spaces, enhancing processing power and efficiency. But Moore's Law isn't just confined to the digital realm. It's also influencing the biological frontier. Our understanding of the human genome is doubling every 7 years. With the Human Genome Project spending over a decade and $2.7 billion to map the first genome from 1990 to 2003, the pace of discovery has accelerated exponentially. Today, thanks to cheaper and faster sequencing, this figure drops to less than 100 days and $200. This accelerating pace of discovery allows us to identify genes linked to diseases like Alzheimer's, develop gene therapies, and even edit genes with precision. Think of CRISPR, a revolutionary technology that allows scientists to alter DNA sequences with pinpoint accuracy. It's like having an advanced pair of molecular scissors that can cut and paste genetic material. This breakthrough is transforming the field of genetics, enabling researchers to correct faulty genes and potentially eradicate inherited diseases. But this progress comes with its own set of concerns. As we delve deeper into the secrets of our DNA, we also introduce new risks. Gene editing, while promising, raises ethical questions. How do we balance the potential benefits with the risk of unintended consequences? The second force converging biology and technology is pushing the boundaries of what once seemed impossible: neurotechnology. At the forefront of this field is Elon Musk's brain-computer interface company, Neuralink. Their mission: to create ultra-high bandwidth brain-machine interfaces to restore full-body functionality to someone with paralysis and to cure diseases of the brain. It sounds ambitious, almost audacious, but it's no idle pursuit. The stakes are incredibly high, and the potential benefits are life-changing. Imagine someone who has lost the ability to move using a computer to type, play games, or communicate simply by thinking about it. Neuralink's work is focused on using tiny wires to decode brain activity and translate it into digital commands. In one recent demonstration, a monkey named Piggy played a simple Pong game using only his mind. Although the technology is still in its infancy, the implications are staggering. If successful, this could revolutionize how we treat neurological disorders like Parkinson's disease, Alzheimer's disease, epilepsy, paralysis, spinal cord injuries, and blindness. But the implications go beyond medical applications. Neurotechnology could also enhance our cognitive abilities. Imagine a world where we can seamlessly interact with computers through thought alone, where we can download information directly into our brains, or even communicate telepathically. While this might seem like a far-fetched sci-fi fantasy, the reality is that we are on the cusp of making this possible. The third and perhaps most transformative force shaping the bio-digital convergence is genetic engineering. We've long marveled at the complexity of DNA, the molecule that carries the instructions for life. Understanding and manipulating this molecule is helping us treat diseases, enhance crops, and even create novel life forms. One of the most prominent examples of genetic engineering is CRISPR, a revolutionary technology that allows scientists to edit DNA with unprecedented ease and accuracy. Think of it as a molecular scalpel that can cut and modify DNA at specific locations, offering the potential to cure genetic disorders and improve human health. CRISPR is just one tool in an expanding arsenal. Others include RNA interference, which silences specific genes, and gene therapy, which introduces functional genes into cells to replace defective ones. These techniques are not just confined to research labs. They're impacting lives right now. Companies like Vertex and CRISPR Therapeutics are using gene editing to treat rare disorders like sickle cell disease and beta thalassemia. The implications of this technology are profound. We're moving from a reactive approach to healthcare to a proactive one. Instead of just treating diseases, we're targeting their root causes at the genetic level. But with these immense capabilities come great responsibility. As we unlock the secrets of our DNA, we must proceed with caution, ensuring that our interventions are safe and that we don't inadvertently introduce new risks. Navigating the bio-digital merge requires foresight and wisdom. We must carefully consider the ethical, legal, and social implications of this technology to ensure it benefits all of humanity. At the heart of this challenge lies our DNA, the blueprint of life. By understanding and manipulating this molecule, we're gaining unprecedented control over the building blocks of life. But with this power comes great responsibility. We must ensure that our interventions are safe, ethical, and equitable. Just as the digital revolution gave rise to new laws and regulations to protect users, so too must we address the unique challenges posed by the bio-digital merge. Moreover, we should embrace diversity in this evolving landscape. Not all innovations will succeed, and that's okay. A true bio-digital convergence will emerge from the best ideas, regardless of where they come from. The convergence of our biology with technology is one of the most significant challenges and opportunities of our time. As we stand on the brink of this brave new world, let's remember that the future is not predetermined. It's shaped by the decisions we make today. Are you excited or apprehensive about the future of the bio-digital merge? What are your thoughts on the challenges and opportunities ahead? Share your insights in the comments below. And if you're eager to dive deeper into the investment opportunities in this space, check out our video titled Top 5 Biotech Stocks Riding the Bio-Digital Wave. Don't miss out on this fascinating exploration. Click on the card on your screen now to keep watching. And if you've enjoyed this journey through the bio-digital merge, stay tuned for more thought-provoking content. Thank you for joining me on this exploration of the extraordinary potential that lies within us. Until next time, stay curious.